Hello, Vaj. Welcome to all of you in my class, Water Resources Engineering. This is the first lecture class and topic is Introduction. My dear Vaj, what is the need of our life is water. Can you give me reply? Anybody? Actually, water is so essential part of our life. Water is so essential part, like air, like food. So water is also a very essential part, and we can't live without the water. But you will surprise that slowly, the drinking water that is called soft water, it's increasing. Sorry, it's decreasing to our earth. First thing, where the start of life, they have made its colony near the big river. You have seen why all cities, why all big cities are near to a river. Thereby, this is only for drinking water. But in the cycle of time, we have done foolishness. We have dropped our sewerage in the river. We have used highly power to the drinking water, and slowly, we have gone to the groundwater. And nowadays, groundwater is going very short. Thereby, groundwater is a bank. Groundwater is not infinitive. It is slowly decreasing. And in Tamil Nadu state and few other states, there is no groundwater. It is a serious problem. So we will study about this topic, about the subject. Thereby, uh, first we will study what is the objective of the water resource. Water resources engineering is the quantitative study of the hydrologic cycle, the distribution and circulation of water linking the earth atmosphere, land and ocean. So surface runoff is measured at the difference between precipitation and obstruction, such as infiltration, which replies groundwater flow, surface storage, and evaporation applications include the management of the urban water supply, the design of urban from sewer system, and flood forecasting. Hydraulic engineering consists of the application of fluid mechanics to water flowing as an isolated environment, pipe, pump, or an open channel, river, lake, ocean. Civil engineers are primarily concerned with open channel flow is governed by interdependent intersection between the water and the channel. So a application, so a application include the design of hydraulic structure such as sewage, conduct dam, and breakwaters, the management of waterway such as erosion protection and flood protection, and environmental management such as prediction of the mixing and transport of pollution is surface water. So hydraulic power development, water supply, irrigation, navigation are some familiar application of water resources. It is water resources engineering involving the utilization of water for beneficial purpose and more recently concerned for the perspective of our natural environmental and meeting of the need of developing country has insist the importance of water resources engineering. So my dear boy, in this subject, in this my lectures, you will show the content of this introduction, hydrology, water cycle, watershed development, integrated watershed management, water conservation and harvesting, basic introduction and hydraulic structure, calculation, and references. Now, first we have come on the introduction. Dear boy, now time water resources engineering is known all person about us regarding the shortest of water. Every places I have seen crises are developing. Very few less persons are saying, water is sufficient, more than public had demand. Water is going to short. So how we will manage it? Water is very enough. If again you will take quantity of water, but 97% is available on the sea, and that is the salty water, and it is a useless for us. Only few 2-3% are available on the earth. It is available on the shape of ice, shape of snow, shape of in the available on the river, lake. So how we will manage that? Why? If we have resources, then no problem to manage. Every year, God has given in the shape of rain. We can store it. But we are not storing it. Why? Because we have not resources. We have not made resources. And when resources has made my seniors, we have also abolished that. So many lakes we have filled up and we have built up the house. Then what is the position to come at today? We have no resources. It means God has given to food us, but we have no pot to keep us. All had dropped out on the earth and again it go to the sea. So question arises, my dear boy, how we will manage, what we can do, because if we'll not put up, if we'll not keep seriously, Sunday, then a day come, but we will not here to see that. We'll not here to see that. Now we will discuss on the how generated this water from sea, how generated soft water. So my dear boy, in the summer season or in the sun rays, water has evolved from sea and it go to where? Up to cloud. And after that, friend, a green, a cold, a some atmosphere will get, then cloud vapor again convert in the shape of rain and yet drop out on the earth. So this is it is the primary technology of hydrology. Hydrology is the study of moment distribution and the quality of water throughout the earth, including the hydrologic cycle, water resources, and environmental watershed substitute. A practitioner of hydrology is a hydrologist working within the field of either earth and environmental science, physical geography, geology, and civil and environmental engineering. Thereby, this is the now time hydrology. Water it evaporate from the sea because the 3-4 area of the earth is sea. All are salty water is there. When it is evaporate, then it is the without salt, vapor, it is vapor, and it go to the upside, made cloud, and when he return to our, that is very good water. But we are unable to keep that. We are unable to keep that. My dear boy, this is a map and showing for water cycle how our water system has done. See, this is the entire sea, and we have made vapor and go to the clouds. And due to the when time when time sun is going away from the earth, the atmosphere has changed and few cooling system has developed in the atmosphere. And on that time, vapor has been melt and maximum hilly area they have dropped out. Or sea area. When the hilly area they have dropped out, they all have maximum freeze on the ice mountain. And other area they have dropped out on the earth. In the entire area, they have taken the perennial system. This is the water cycle. From earth, it has go to the cloud. There, they have converted in the shape of cloud, vapor, all vapor. And when they feel some cool atmosphere, they have again come to the earth, and this is the system running. This is the system running. So, my dear boy, you have seen water cycle. Now, a question is rise when yeah, the water vapor converted in the shape of rain and come to the earth. Vapor convert to the earth. Then, then, then it is the shape of rain and heavy. This is the maybe cause of flood. Flood caused extensive damage during 91-95. Flood related damage total more than 2000 billion US dollar. So why this is our why this is we are suffering? Because we have not keep the resources. And one position is another. The problem is due to cool atmosphere and due to greenery, cloud converted to the rain in that area. And so in the northeast Bihar Himalayan belt has got much water. And Gujarat, Rajasthan, Uttar Pradesh, Delhi are facing the drought problem. My dear, what? This is the serious one. This is the serious error. You can see in this picture, this is the drought. So we are now thinking, if in our houses water is coming, in my country water is coming, then we are planning to transfer from flood area to drought area. This is we are planning from flood area to drought area. And now it is possible. We are thinking now it's possible. Engineers have made so many reports. Few has started, few has completed, but so far now it is not sufficient. Now it is not sufficient. It is and it is not a problem of our country. It is entire the world. The future is not best if we will not think. People are saying, my dear boy, the third world war will be applying for water. So this is the picture. Up now we have calculated how much water we have demand. How much people? 125,000 crore. We Indian, and it is a big population, and every person use in the small area 10 to 50 liter water, 50 to 100 liter water, and big places it is used 100 to 600 liter per a day per person. So this is human use table. How much water used in our agriculture, and how much water used in our livestock. So position is water stress based on the human consumption and linked to the population growth. The domestic requirement is 100 liter person per day and 600 liter person per day. Associated agriculture, industrial, and energy need 20 to 40% per day. So total need 840 cubic meter to 1040 cubic meter person per year. Now we will discuss about how we can save our water in our country. Actually, first thing, my dear boy, soft water is using in the human, in the livestock and agriculture needs also. So integrated water resources, river basin resources, surface and ground, demand conjunctive and non-conjunctive, and supply facility, mega to micro, and human and ecosystem. Engineering with social economics and scientific need. And food production, India had 2% of world's land and 4% of fresh water. So 16% of the population and 10% of the cattle are also dependent upon it. Graphical area 329 million hectare acre, of which 47% and 142 million hectare acre is cultivated. 23% forested and 7% under non-agri use and 23% waste. India land resources, irrigation and food production. So now our country, my dear boys, per capita available of land 50 years ago was 0.9 hectare, could be only 0.14 hectare in 2015. And out of cultivated area, 37% is irrigated, which produce 55% food, and 63% is the rainfed producing 45% of the 200 meter of the food. In 50 years, ultimate proportion could be 50-50 producing and 75% or 25% of the million hectare meter are required. Now withdrawal of the water 2050 available. Dear boy, India yearly requirement in 2050 for growing food and feed at 420 to 500 million tons and is equal to 628 to 807 VCM. Drinking water plus domestic and municipal use for rural population and 150 LPCD and urban population 220 LPCD is equal to 90 to 110 BCM. Now, my dear boy, withdrawal of water. We will discuss the withdrawal of water. Hydropower and other energy generated 63 to 70 BCM. Industrial use is equal to 81 to 103 BCM. Use of water by evaporation from reservoirs is equal to 76 BCM. Environment and ecological is equal to 20 BCM. Then uh, total required 970 to 1200 BCM and availability 1100 to 1400 BCM. Then I was telling to you about that we are unable to keep, otherwise God is giving sufficient. So where did the water come from? New dam, groundwater, underdeveloped, demand management, water saving, increasing in efficiency, reduce evaporation, water productivity, increase in crop per drop, and trade virtual water, import food. So, my dear boy, when we are constructing new dams, so it has stored water, so the flowing water is not going to the river. So it is called it has less. But if we have constructed, then we can try to full at rainy season. That is the good. Now groundwater, underdeveloped, demand management, water swing, increase in efficiency, reduce evaporation. Water saving, my dear boy, it increase efficiency and reduce evaporation. Why? Because just wait. Dear boy, if you have made going to them, first your water, you see a river, and water is flowing in this river. So what reaction first will do? The water, all water, evaporation, all. If we have constructed a dam here and store the water, so no water, no high quantum of water will come in river. So evaporation will be short. Only here evaporation will be. So he's saying water saving, increase in efficiency, reduce evaporation. Water productivity increase in crop per drop. Or take the trade, import food, virtual water. Now, my dear boy, we can save total water management for sustainable development. Here you can see one type where flood are available. They have get problem from the water. One side, rain is not available, water is not available. They have searching water. So this That's how we manage. What it means manage? Can you understand? Wait. There was suppose you have a two area, area A, area B. Here is 100 quintal food grain are available and use are 20 metric ton. 100 metric ton are available. Use 20 metric ton. Here position B, population is huge. Here 10% food grain available and use how much use? Use 90. Then this is called management. How will do? The rest of 80% you will transfer to this. This is the called management. Now, my dear boy, in the case of management, he will be transferred to surplus food grain to a route zone B. Like that, water should be transferred from route A to route B. Now, water conservation. So, important step for the solution to issue of the water and environmental conservation is to change people, its attitudes and habits. Case conserve water because it is right thing to do. So what you can do to conserve water? Use only as much water as you require. Choose the tap will be after use. And while brushing or other use, do not leave the tap running. Open it only when you require it and see it that are the seeking tap. Clear? So use of washing machine that does not consume too much water. Do not have the tap running while washing efficient clothes. So these are very good things. We use very less water. Now water conservation. Install a small shower head to reduce the flow of the water and water in which the vegetable and fruit have been washed used to water the flower and plant and all the end of the day. If you have water left in your bottle, do to throw it away and pour it over some plant and reuse water as much as possible. So change in the attitude and habit for water conservation. Every drop counts. Now rainwater harvesting. Now this is a question, my dear boy. How you will store the rainwater? Suppose if This is your house. If this is your house and this is your premises. So, my dear boy, if rain is falling in the rainy season, so see, this is rain, this is rain. So, what you will be do? You will make a pit and try it all the roof of water will be go on the earth. And if one camphor will be full, then it is very happy thing. Now we will question what is the camphor. Dear boy, yeah, this is the earth and this is camphor. This is the camphor. We have from the last 1,000 years, if rain drop is falling on the earth, so this camphor has been going to full. But my dear boy, during this time, slowly we have forget our duty. We have taken groundwater from earth, and who will be fulfilled? So the duty of first generation, when forget, the problem will be faced in second generation, third generation. Correct? Now, if you will make your house like the picture, if water will be dropped on the this type of pit, so slowly water, it will fill the camp. So it is called rainwater harvesting. It is called, my dear boy, rainwater harvesting. So rainwater harvesting yield copious amount of the water for an average rainfall of 1,000 mm approximately. Your million liter of the rainwater can be collected in a year. In an acre of the land, 404 cement per square meter post evaporation. It is the post evaporation. So this is rainwater harvester and root rainwater. One thing I want to bring your one thing, my dear boy. Suppose nowadays our rain harvesting system are developing. This is a machine. This is a rainfall doing. this, and this. This type of watershed and water management is very good for the crop. Water go through the root and very short water you can irrigate everything. So root rainwater harvesting, land-based rainwater harvesting, watershed-based rainwater harvesting for urban industrial environment, roof and land-based rainwater harvesting, public, private office and industrial building, and prevent land recording operation. So now rainwater harvesting advantage. What is advantage? So provided self-sufficiency to water supply, reduce the cost of pumping of groundwater, provided high quality water, soft and low luminous, and improves the quality of the groundwater through dilution when the recharge, and reduced soil absorption flowing in the urban area. The rooftop rainwater harvesting is less expensive and easy to construct, operate and maintain. And rainwater, rain top, so rain harvesting has been expensive and easy to construct, operate and maintain. And desert rainwater harvesting only really. In desert, rainwater harvesting is only really. In silence or coastal area or Iceland, rainwater are very good. So my dear batch, you have listened soundly my lecture. I am very thankful. So we will go on the MCQ, which you have listened the lecture. This is the dam site, Rockfield Dam. This is Rockfield Dam. So this is the MCQ. So I will ask few questions and you should be replying. A multi-purpose reservoir is the one which is designed for one purpose. What is correct answer? Answer is B. Planned and constructed to serve various purposes. Now, second question, a rain gauge should preferably to be fixed where? Correct answer is C, in an open space. And next question, repelling ground in the and aligned. So, what is answer? Answer pointing upstream. So, next question, a hydroelectric scheme operating under the near head of a steam well. So, what is the answer? Answer is C, high head scheme. And a heterograph is the graphical representation of to which? Answer A, rainfall, intensity and time. Now, a land is known as the waterlogged. So what means? Answer C, capillary ring, capillary ring reach the root zone of plant. Next, 70% index of wetness means what is? What is, my dear boy? It is rand deficiency of 30%. And a deep well, what action take? Answer is B, has more discharge than a shallow well. Answer A, for a current meter is used the measure of. So answer A, velocity of flow of meter. And next question, a divide wall is provided. Where divide wall provided? Answer A, at the right angle of axis of flow. And this is the reference book where we have taken this material. And I am very thankful for your insist. You have taken interest in my lecture. And we will meet lecture number 2 to further. Thank you for all of you again.